initial without any doubt. So change in V will be equal to V final minus V initial. So bigger value minus a smaller value, delta V will be always positive. So in case of expansion, what is the work done formula? Work done equal to minus P external into delta V, and delta V is our positive bacha. So minus P external into delta V minus plus minus. So work done will become negative. So what is the star point you have to write down in your notes? Whenever I am saying expansion, volume increase, work done will become negative. Okay, please note down as it is in your notebook, short notes. What is the star point? If expansion, volume increase, work done will be negative. If compression, volume decrease, work done will be positive. So as soon as it is written gas expand, so you see in which option it is negative sign, that will be our answer. So here all four option has negative sign, just I have told you how to eliminate. Okay, so from this to this, from means it is our initial and it is our final. So V initial is 3 liter, V final is our 3.5 liter. So change in volume will be how much? Final minus initial, 3.5 minus 3, that is 0.5 liter. Okay, now after that we will see here P external, external pressure how much they have given bacha? 180 m. Now tell me, calculate the PV work done. PV means pressure into volume work done. What is the formula? Everyone, minus P external into delta V. P external how much they have given? 180 m. Delta V how much you have got? 0.5. So what is the answer? Minus 0.5. What will be the unit? Volume is in liter, pressure is in ATM. So liter ATM. And in the option also, all the options are in liter ATM. If it is in joule, now we need to convert liter ATM into joule. So which option will be right option? Option number A. Simple or not? I have given so much of time because it is the first question. From the next question, we will start solving quickly. Clear? Over? Okay. Now let us solve. You guys solve each and every question. Take a rough notebook, solve. Okay. Next question. An ideal gas enclosed in a cylinder fitted with a frictionless, weightless piston. Okay. Pushes it outside. Pushes it outside. Okay. What would be the sign convention for the work done? Okay. So pushes it outside. I am saying it is pushing it outside. It means that work done by the system. Who is doing work here, bacha? Work done by the system. When work done by the system means it is a case of expansion, and expansion means work done will be negative. Okay, so a gas is there, it is enclosed in a cylinder, and this cylinder is fitted with frictionless piston. Okay, and it is pushing outside. It is pushing outside. So what is happening? Work done is done by the system. System is pushing it outward. So what is happening? Gas is expanding, volume is increasing, gas is expanding. So expansion means work done negative. Conceptual question. Clear? Next. Question number 3. 1 mole of an ideal gas. Okay, fine. Mole is 1 mole. As soon as you start reading question, start writing what is given. That is how we should proceed to the question. Of an ideal gas, temperature 25 degrees centigrade, expands in volume from 1 liter to 4 liter. So V initial 1 liter, V final 4 liter. So change in volume 4 minus 1, how much bacha? 3 liter at constant temperature. What work is done if the gas expand against vacuum? They are asking you what work is done if the gas is expanding against vacuum. Please write down some star points. So whenever they will use this word, work done in vacuum, or if they will use this word free expansion, if they will use this word free expansion, okay, or if they will use this word isochoric, or else what they will use? Isochoric, vacuum, free expansion, isochoric, all these three cases work done is 0. Please remember, write down it in the short notes. Vacuum, free expansion and isochoric, work done 0. Vacuum, free expansion, isochoric, work done is 0. Okay. So against the vacuum, vacuum means bacha no pressure, right? Pressure, no pressure. So pressure will not be there. So work done will be 0. Clear? Okay. Note down next question, question number 4. 2 moles of an ideal gas, 2 mole, okay, of an ideal gas, mole is given to into a vacuum. As soon as you will see vacuum word, free expansion word, isochoric word, work done will be 0. So, option number 4, clear. Next question, free expansion is, okay, let me check. Free expansion is the expansion against strong opposing force, the expansion against weak opposing force, the expansion against no opposing force. Name it is clear, bacha. Free expansion. Okay. So whenever I am saying free expansion, freely it is expanding. Okay. And there is no force. Na? There is no force. And that is why work done is 0. Na? That's why I have told you. Free expansion is there, vacuum is there, or isochoric is there, work done will be 0. So, free expansion means expansion against no opposing force, no opposing force is there. Next question number 6, 1 mole of a gas occupied 2 liter volume is expanded. Again expansion bacha. So, expansion means work done will be pakka negative. Okay, that is one thing clear. Against a constant external pressure. Pressure is how much they have given? 1 atm to a volume of 10 liter. So 2 liter to 10 liter. So initial was 2 liter, final was 10 liter. Before I am explaining, solve it and tell me the answer quickly. So what will be the delta V here? Final minus initial, 10 minus 2, 8 liter, and pressure is 1 atm. So what will be work done? What is the formula for work done? Minus P external into delta V. Minus P external 1, delta V is 8, answer is minus 8 liter atm. Do we have any option like that? No, in the option we have joule, joule, joule and joule. So I have taught you, those who don't know, write down as a star point, how to convert liter atm into joule. So we will multiply it by 101.3. We will multiply it by 101.3. So 101, if we are taking it as 100, so 100 into 8, it will come around 800. So 1.3 means more than 800, right? So option will be C option. No need to solve. You can just check here. 101.3 I can consider it as 100. So 8 into 100, it should come 800, but it is 101.3, more than 100. So answer will also come more than 100. Who is more than 100? 810.4, that will be our answer. So let us solve question number 7. Start solving. Do it fast, quickly. Before I do it fast. The work done when 2 moles of an ideal gas. Okay, mole is how much? 2 mole of an ideal gas is compressed. Here compression bacha. Compression means work done is negative or positive? Work done is positive. Compression means work done positive. If work done is positive means pakka. Which option will not be there? B and C will not be there. What if 3 is negative? Directly we will take na. Sometimes they will give this question in this type of question in NEET and J to save your time. Clear? So that if you know the trick, you can solve that question within 10 seconds, within 20 seconds, and you can move to the next question. Whenever they will make lengthy paper, sometimes they will use all these techniques. Okay. From a volume of 5 meter cube to 1 decimeter cube at 300 Kelvin under a pressure of 100 kilopascal. So mole is 2 mole. Pressure is how much, bacha? 100 kilopascal. So pakka kilopascal I need to convert into pascal. Okay. Next, what they are giving volume. Okay. What is the volume? Initial volume 5 meter cube, and what is the final volume here? 1 decimeter cube. Okay. So 1 decimeter cube we will convert into meter cube. So how to convert? So those who don't know, you please write down. 1 decimeter cube to meter cube multiply by 10 to the power minus 3. Okay. So 1 into 10 to the power minus 3 meter cube. Clear? Okay. And kilopascal will convert into pascal. So we will say here 100 into 10 to the power 3. Now what is the formula for work done? Work done is equal to minus P external into delta V. P external is how much, bacha? 100 into 10 to the power 3. Directly I am writing here 10 to the power 5 pascal into volume. Volume is in meter cube. Okay. So initial is 5 meter cube and final is 10 to the power minus 3. So delta V will be how much? 10 to the power minus 3 minus 5. Okay, how much it is going to come? So 10 to the power minus 3, we can take it as 0.001 minus 5. Okay, so it will come around minus 4.999 meter cube. Okay, so work done, minus 10 to the power 5 into minus 4.999, minus minus will become plus. Okay, and when we will multiply with the 10 to the power 5, you know, it will become our 4.999 into 10 to the power 5. Okay, and you please write down one star point. Those who don't know the conversions, please write down one star point. Pascal meter cube is nothing but joule. Pascal meter cube is nothing but joule. So what is the unit here? Pressure I have taken in the Pascal and volume I have taken in meter cube. So here the unit is Pascal meter cube. Na? So answer should come 4.99 into 10 to the power 5 joule. But in option it is given kilojoule, kilojoule. So how to convert joule into kilojoule? We will divide by 1000. Okay. So it will come 4.99 into 10 to the power 5 into 10 to the power minus 3. So it will become 4.99 into 10 to the power 2. Okay, that will come around 499.9. Which option? 499.9? Option number 1. So star point, Pascal meter cube is joule. Pascal meter cube is joule. So now liter, how to convert liter ATM? Multiply by 101.3. Okay, how to convert Pascal meter cube? Pascal meter cube is equal to 1 joule. Okay, so thermodynamics questions will be like this only. Now calculation will be little lengthy. Over. Okay. Okay, fine. So let us solve question number 8. Okay, work done in expansion. Expansion means work done will be negative of an ideal gas from 4 decimeter cube to 6 decimeter cube. 1 decimeter cube means 1 liter. Those who don't know, write down it as a star point. Against a constant external pressure of 2.5 atm, change in volume. So from here, what will be delta V, bacha? 6 minus 4, 2 liter or 2 decimeter cube. And pressure is how much? 2.5 atm. We used to heat up 1 mole of water at 20 degrees centigrade. 20 degrees centigrade means temperature is constant. Okay, why I am writing all these things, we will use it. Okay, what will be the final temperature? What they are asking? Final temperature, T final. They are asking specific heat of water. What they have given? Specific heat of water. So specific heat they have given. So what is the formula for specific heat? Tell me first. Heat Q will be equal to mc delta T. What is the formula for specific heat? Q equal to mc delta T. Q will be our heat, M will be here the mass, the given mass. Okay, C will be specific heat, delta T will be T final minus T initial, right? So we need to find out mass. Okay, so how we will find out mass, bacha? They are saying water and mole is given. So we know mole is equal to given mass by molar mass. Given mass by molar mass. Okay, so from here given mass equal to mole into molar mass. Mole is 1 mole. Molar mass of water is 18. So how much mass water they have given? 18 gram. So I will write down here 18. Specific heat, how much they have given? It is given in joule only. No need to convert. 4.184 into delta T. Final minus initial. Final only they are asking. Initial is how much, bacha? 20 degrees centigrade. Centigrade you will use? No, Kelvin. So we'll say 20 plus 273. Okay, 293 Kelvin. So I will write down here 293 Kelvin. Q, I don't know. So let us find out first Q. How we will find out Q? Temperature is constant, right? So temperature is constant means delta U equal to Q plus W. So temperature constant means it is isothermal process. Isothermal process means change in internal energy 0. So from here work done will be equal to minus of Q, or Q will be equal to minus of W. You will not get all these things in one time, right? So you have this type of questions, you have to practice again and again, so that, see, when we are studying in the classroom from a teacher, that time our target should not be to solve each and every question. That time we are learning, right? So you should sit in my class with that perspective of brain that we are learning, right? But yeah, once I have taught you this question, again if the same pattern question will come in your NEET exam, you should be able to solve. Only this is the difference, right? Those who will revise, those who will practice, they will become intelligent, slowly, and when the same pattern of question will come in your NEET exam, you will be able to solve it and you will be able to become doctor, engineer, crack NEET and JEE, whatever exam, it is clear. So it is never about in classroom how you are able to solve, okay. It's always about how much you are learning, retaining, and then similar type of question you are solving in your NEET exam. So these questions you should mark star in your DPP and solve again and again. This question should directly go in your notes, okay. Then after that, so we need to find out work done, because negative of work done will be heat. What is the formula for work done? Minus P external into delta V. P external, how much bacha? They have given 2.5. V, how much we have calculated? 2 liter. Okay, so minus 5 liter ATM, minus 5 liter ATM, but specific heat and all they have given in joule. So we need to convert work done in joule, heat in joule. So I will write on minus 5 into 101.3. So it will come around minus 506.5 joule. So Q will be equal to minus of W. So minus will become plus. So plus 506.5. Okay, now let us solve here. So Q, how much we have got, bacha? Okay, so Q, how much Q we have got? 506.5 equal to 18 into 4.184. When we will do, we will get here 75.312. Okay, T final minus 293. Okay, so 75 will come this side. 506.5, 75.312 equal to T final minus 293. So from here we will get T final equal to 506.5 by 75.312 plus 293 will come this side. When we are dividing it, we are getting here 6.725 plus 293. When we will add it, we will get here 299.7 Kelvin. Okay, and but the answer is in Celsius. Can you see? The answer is in Celsius. So what I will do, then I will subtract 273 to convert it into Celsius. So I will get 26.7 degrees centigrade. So option number D will be the right answer. Clear? Okay, let us see the question number 9. The internal energy of a substance increase with increase in temperature. Yeah, correct. You please remember, write down this also as a star point. So internal energy is a function of temperature, directly proportional. If temperature increases, internal energy will increase. Okay. Now let us solve the next question. Question number 10. There is no change in internal energy for an ideal gas at constant temperature. Very true, because constant temperature means delta T 0, and we know state function is internal energy is a function of temperature. Internal energy is a function of temperature. So if change in temperature 0, so delta U will be also 0, right? Okay. So there is no change in internal energy, means delta U is 0 at constant temperature. That is isothermal. Write down all these points as a star point. For isothermal, constant temperature, delta U 0. Reason, internal energy, yeah, is a function of temperature only. So which option? A option. Both assertion, reason correct, and reason is the correct explanation of assertion. Let us see question number 11. If the door of a refrigerator is kept open, the room in which the refrigerator is kept, what will happen? When you will, so most of the people will think when we will open the refrigerator door, so the room will start getting cool. No. Okay, so the room will start getting heat up. Why? So whenever you will open the door of a refrigerator, the compressor will start working, bacha. The compressor will start working. When the compressor will start working, large amount of heat is released outside. So as a result, what will happen? The room will start getting hot instead of cold. Okay. Question number 12. If 400 kilojoule means pakka, okay, options are also in kilojoule, no need to convert. Let us check. If 400 kilojoule work is done by the system, negative, on the system, positive. Okay, work done by the system, negative, work done on the system, positive. Write down this is a star point, and 1 kilojoule heat is given to the system. So heat we are giving to system, heat we are giving to system. When we will give the heat, it means heat is increasing, so heat is positive. Okay, heat given to the system positive, but work done on the system negative. Oh, sorry, positive. Okay. Then what will be effect on internal energy? So what is the formula for delta U? FLOT, thermodynamics first law. Q plus W. Q is what heat is given to the system positive. So plus 150 work done by the system. So minus 400, both are in kilojoule. So we'll get here minus 250 kilojoule. So minus means decrease. So internal energy is decreasing by 250 kilojoule. Option number B. Clear? Easy? Okay, so sign convention is very important. So you can write down as a star point. Work done on the system positive, work done by the system negative. Heat when we are giving to the system positive, heat when it is released negative. Clear? Okay, let us solve question number 13. A system is provided 50 joule of heat. So we are providing, it means Q will be positive plus 50. And work done on the system, bacha, on the system means also work done positive. So Q is plus 50, work done is plus 10. Change in internal energy will be how much? Q plus W, that is 50 plus 10, that is our 60 joule. Simple. Okay, these are very simple questions. Okay, now let us see question number 14. A system absorbs 600 joule, bacha, absorbing na positive only, heat is increasing, and does work equivalent to 300 joule on its surrounding. So work done the surrounding, है ना, work done is on the surrounding. It means who is doing work? System is doing on the surrounding, na bacha. It is written work done on its surrounding. So who will do work on surrounding? System. It means work done by the system case. What is the case here? Work done by the system. So take work done negative. Don't take work done positive here. Okay. So here it is work done on the surrounding, beta, not work done on the system, right? So on the surrounding means who will do the work on surrounding? System will do. Means work is done by the system. Why the system means negative. Okay. So what they are asking? Change in internal energy, same thing. Okay. So delta U will be equal to Q plus W. Okay, Q is how much here? Plus 600. Work done is minus 300. So answer will be 300 joule. Okay. Now let us see here question number 15. Delta E is always positive when. Okay. So delta U will be equal to Q plus W. So when will be delta U positive, bacha? When we will have Q also positive and work done also positive. It means Q plus W is our positive thing. Clear? Okay. So system absorb heat. System absorb means heat increasing positive, and work is done on the system or work is done on it. So work done on system is also positive, both positive, delta U will be positive. So first case, heat absorb, work done on the system. Next question number 16. For a particular process, Q is equal to minus 10 kilojoule and work done is equal to 25 kilojoule. Which of the following statement is true? Okay, so they are saying here, let us see the statement what they are asking. Slowly we will find out. Heat flows from the surrounding to the system. Okay, now you see here, heat is how much, bacha? Heat is negative. Heat is negative means heat is released, है ना? Heat is released. System to surrounding, heat is released. What they are saying, heat is flowing from surrounding to system. Surrounding to system means Q will be positive. No, heat is negative. This option is wrong. The system does work on the surrounding. So work done here is positive plus 25, and on the system means also work done will be positive. Okay. So it means, and but here see in the question, in the option, the system does work on the surrounding beta. It is not given system. Again the same thing. So work done on the surrounding means what? Work done by the system, and work done by the system should be negative. So this option is also wrong option. Clear? Delta U is minus 35 kilojoule. Okay, let me check here. So delta U equal to Q plus W. Q is how much? Minus, then W will be how much? 25. So how much it is going to come? Not minus 35. Okay, minus 15 kilojoules. So C option is also wrong. So what will be the right option? None of the above is true. So I hope with each and every option you are getting the conceptual clarity. If not, watch the video again, see the question again. Still if doubt is there, comment down below. Okay, I will clarify. Next to question number 17. A system absorbs 10 kilojoule. So absorb means what? By the time you should be able to tell the convention. Absorb means what? Positive. Heat is positive. Okay, so Q equal to plus 10 kilojoule and does 4 kilojoule of work. Okay, so work is done by the system doing the work. So work is done by the system. By the system means negative, minus 4 kilojoules. So delta U chumma question. Okay, Q plus W equal to 10 minus 4, that is 6, and it is plus or minus? Plus. Plus means increased by 6 kilojoule, minus means decreased by 6 kilojoule. Okay, a gas expand, again expansion. Tell me fast quickly now. Close your eyes and think. Expansion means pakka work done should be negative. Okay, isothermally, what I have told you for isothermal, isothermal means delta U will be 0. Okay, against a constant external pressure of 1 atm. Okay, constant external pressure is P external is how much bacha? 1 atm from a volume of 10 decimeter cube to 20. So decimeter cube is nothing but 1 liter. So I can say delta V is how much? 20 minus 10, that is 10 liter without any doubt. It absorbs 800 joule of thermal energy. Absorption means Q is how much? Plus 800. Okay, then delta U they are asking, and in the option bacha 0 is not there. Okay, in the option 0 is not there, so we need to solve it. Clear? Okay, how we will solve? So delta U will be equal to Q plus W. Q is how much? 800. W is not given. Let us find out. How to find out W? Minus P external into delta V. So 800 plus minus P external. P external how much? 1 into delta V, how much we have calculated? 10. Okay. So how much we will get here? 800 plus minus 10. Please don't reduce 800 from 10 here. How will you reduce? It is liter atm. It is joule. It is joule. It is liter atm. So means we will convert first it into joule. Multiply by 101.3. Okay. When you will multiply by 10. So it will become here 800 minus 1013. Okay. Which will come around minus 213 joule. Minus 213 joule. Clear? Now let us solve question number 19. A system absorb 20 kilojoule. Absorb means again plus bacha. Heat is how much? Plus 20 kilojoule and does 10 kilojoule of work. So work done is done by the system. By the system means work done will be minus 10 kilojoule. In turn chumma question, delta U equal to Q plus W, 20 minus 10 equal to 10 kilojoule. Simple. Okay. Okay, let us solve question number 20. If an electric motor produce 15 kilojoule of energy as mechanical work. So produce means done by the system. System is producing, system is doing work. By the system means work done negative. So work done is given minus 15 kilojoule. Very simple. Lost 2 kilojoule means heat is how much? Minus 2 kilojoule each second as a heat. Okay, then the change in internal energy. So delta U will be equal to Q plus W. Q minus 2, W minus 15, it will be minus 17 kilojoule. Option number C. Now let us solve question number 21. Change in internal energy when 4 kilojoule of work is done on the system. Change in internal energy when 4 kilojoule of work is done on the system. Work done on the system means what bacha? Plus. Okay. How much? 4 kilojoule. And one heat is given out. Given out means released. So Q is how much bacha? Minus 1. So delta U will be equal to Q plus W. These all are for your practice, right? So here we will get plus 3 kilojoule. Option number D. Very simple question. Clear? Okay. Now let us see question number 22. Which of the following is the correct representation of first law of thermodynamics? Which of the following is correct representation of first law of thermodynamics? Okay. So what is the first law of thermodynamics? Delta U is equal to Q plus W. Delta U is equal to Q plus W. So from here W will be equal to delta U minus Q. Now where is the, so here U they have represented as E. Internal energy sometimes represented as capital E also. So which option bacha? W equal to delta E minus Q. Option number 1. Now let us see question number 23. The first law of thermodynamics is only, so first law of thermodynamics, remember what I have told you, first law of thermodynamics is based on energy conservation. So it is based on the law of conservation of energy. First law of thermodynamics tells us that energy can neither be created nor be destroyed. It can be only transferred from one place to another. So here we have finished our DPP number 2 also.